this is a circle, not a triangle. But do you guys remember how we got these values right here? At each of those locations, we drew a triangle. Is that okay with everybody? So I'm going to outline it one time on here. We basically said, if you're looking at the 30-degree location, we built a triangle like this when we originally came up with these numbers. That's kind of how we figured them out, okay? If this was your triangle and this is your 30-degree angle in here, normally, if you're doing a calculation like sine, you calculate sine of an angle by doing opposite over hypotenuse. Is that okay with everybody? That's how we normally do it. So if this is the triangle and this is where the 30-degree angle is, then this would be the opposite and this would be the, oh, sorry, not the hypotenuse. This would be the hypotenuse and this would be the adjacent. Is that okay with everybody? Okay. If I went to an angle in a different quadrant, so I'm going to just outline a different one. Let's say I looked at like 225 right here. The way we made that triangle is we connected it back. That's why we counted it just like a 45-degree angle. We said that's like a 45-degree angle, just turned a different way when we talked about reflecting the triangles yesterday. If we were looking at that triangle and trying to calculate, this would be the opposite again. This would be the adjacent. This would be the hypotenuse. Okay, is this okay with everybody? So I could draw a triangle at any of these locations, and you would see me do the same thing over and over and over again, okay? Notice that every time the side that I call the opposite is this distance. Even in a triangle down here, the side that I call the opposite is this distance. And you actually figured out this distance already, right? This distance right here on a graph is negative rad 2 over 2. That was the y-coordinate at that point. This distance right here on the graph is 1/2. That was the y-coordinate at that point. The opposites in these triangles are the same thing as the y-coordinates that you wrote down before because that's how far it is. So we can actually take opposite, and everywhere one of our trig functions uses opposite, if we want to use this circle instead of having to build a triangle every time, we can replace it with y. On this circle, the opposite side of the triangle you built is the same thing that I used for the y-coordinate when we were filling in the circle. Is that okay with everybody? Okay. What other trig function uses opposite somewhere in its ratio? Does cosine use opposite? No. Does tangent? Tangent uses opposite over adjacent. Again, whenever we're using opposite, if we're using this unit circle, we can just use the y-coordinate because the y distance is the same thing as the opposite piece of the triangle. Okay. What about the adjacent piece of the triangle? So at 30 degrees, this is the adjacent piece of the triangle. That's the same thing as the distance we had to go in the x direction. Down here at 225 degrees, this is the adjacent side of the triangle. That's the same distance we had to go in the x direction, okay? So all of our adjacent sides, when we put together this unit circle, they are the same things that we were using yesterday as the x coordinate. So everywhere that we see adjacent, we can replace that with x, okay? And adjacent shows up in the cosine ratio also, so we can replace that adjacent with x. Is that okay with everybody? So now that we drew it a different way, we don't just have to use words like opposite and adjacent. We can use x coordinate and y coordinate because we already did all the work to measure all those distances on this circle. Now we're looking at, the hypotenuse is the only thing that we haven't gone through. So the hypotenuse of every triangle is this piece right here, or this piece right here. What are those pieces in our drawing? Besides being the hypotenuse of the little triangles I'm drawing, what else do they represent on this unit circle? These pieces, they go from the center and they connect out to our marking for our angle. What would that be? What part of the circle is that? A line that goes from the center and connects out to the edge. The radius, okay? So the hypotenuse really of all the triangles we build every time is the radius. But remember how we were allowed to choose how big we wanted the circle to be? Like big triangles and small triangles, they all still had the same sines, cosines, and tangents. So how big did mathematicians pick the radius to be in the unit circle? 1, okay? So every time we see hypotenuse in these fractions, we could replace that with radius, and for our picture here, the unit circle, specifically the radius is 1 unit. Okay? So this gives us new ways to calculate sine, cosine, and tangent where we don't have to draw a triangle anymore. We can use the circle. The reason it's useful is it means that you guys can actually go calculate something like the sine of 450. You could never put 450 degrees in a triangle, but in the circular structure, we can figure out where that is using these ratios instead of having to call it opposite over hypotenuse. You can't forget that because you'll still need it, but these are new ways to remember it. So this means when we're calculating sine of an angle, we can do it by doing, instead of opposite over hypotenuse if we don't have a triangle picture, if we can use our unit circle, we can do y divided by 1, and y divided by 1 is just y. That means if you know the unit circle or have it in front of you, you can calculate the sine of any angle just by using the y coordinate at the same spot of that angle, okay? And then for cosine, the cosine of any angle can be calculated by doing x divided by 1, okay? But x divided by 1 is just x. This means I can calculate the cosine of any angle you have marked on the circle if I just know the x coordinate at that same position. Okay? The tangent isn't as friendly. So the tangent can be calculated by doing this, but I have to actually do division. I have to take the y and I have to divide it by the x. So hopefully now you have a little more understanding of why they created this structure. Now, if somebody says, what's the cosine of 45 degrees? If I know the unit circle and I know that at 45 degrees, the coordinates say rad 2 over 2, rad 2 over 2, the cosine is the same as the x coordinate. So the cosine of 45 degrees is rad 2 over 2. Is that okay with everybody? All right. This information you're not going to be given. When you guys take quizzes and tests, I am going to give you a filled out version of this, meaning all these spots that you have marked around your circle will be filled out. You have to know how to use the tool though, okay? So that's what we're going to go through next. So you really want to solidify that sine, because it uses the opposite, is really now the same thing as how we've drawn it with the y coordinate. That cosine is like the x coordinate and tangent is like the y divided by the x. So these are the things that you want to know. Okay? Does that make sense to everybody? What you're responsible for versus what I'm giving you. So I'm not making you memorize all the numbers and the patterns, but you have to understand how to use the tool. So you'd have to know that this is how they relate to what's on there. Okay? And then what we're going to go through is we're going to go through and do 9 examples essentially. Some will require some work, some won't require any. Okay, I've kind of grouped them in groups of 3, sine, cosine, tangent, sine, cosine, tangent, sine, cosine, tangent. Here you see numbers that you should see labeled on your circle. Here you see numbers that are bigger than 360. And here you see negative numbers. So we're going to kind of talk about those different situations. Okay. All right, any questions so far before we go through and try and do some of these? I'm going to put them on the screen here so that you guys can see them a little bit better in groups of 3. So I'm going to erase what's here now. Sorry, I'm going to use a bigger eraser. All right, I know you can't see the numbers on my unit circle. You have one in front of you, and we went through what your numbers should be yesterday. So my hopes are that you're using that. Okay, so let's look at these first 3 problems. So we're going to calculate the sine of 180, cosine of 240, and tangent of 330. So remember, when you read that you're doing a sine calculation and you know it's something that you can use the unit circle to help you with, so it's a number that's like on there. When you see the word sine, what should you be associating that with in your head? What did we just write down? The sine can be calculated using the y value. When I see cosine, I should be associating that with x value. And when I see tangent, I should be associating that with the y being divided by the x. Okay? So when I see sine 180, the thing I have to know in my head is that I would be using the y coordinate because I know that the sine can be calculated using the same information from the y coordinate. Now I need to use my unit circle and I need to go to this location. So I need to go to 180 degrees. That's marked on here. So here's 180 degrees. So what is the sine of 180 degrees? Look at the y coordinate. It is 0. So the sine of 180 degrees is 0. So those special triangle patterns, and mathematicians being super smart and setting the radius to 1 because they could set it to whatever they want, made it so that the coordinates just match the sine and the cosine values. Okay? All right, so for cosine of 240, with cosine I should be thinking x, and I need to go to the 240 degree location. So look on your circle, find the 240 degree location. You want to use the x coordinate from that location. So the cosine of 240 degrees would be -1/2. Right, so if you know how to use it, I'm giving you a great gift. If you don't know how to use it, it might seem like giving you this is not that important at all. Okay? Tangent of 330, for tangent, I should be thinking, okay, I have to take the y and divide it by x, so I want to go to the 330 degree location, so that's all the way around to here. That spot has coordinates rad 3 over 2, comma, -1/2. The tangent is calculated by the y divided by the x. So to calculate the tangent, I need to do the y coordinate divided by the x coordinate. And the reason I'm writing it out horizontally instead of in a fraction is because it's a fraction divided by a fraction. So it's going to help me to write it out this way. And so just like you guys have done a few times in this course, you do have to know how to do division with fractions. So this means we have the first fraction being multiplied by the reciprocal of the second fraction. The 2's are able to be canceled here. And so we get -1 over rad 3. That's an answer, but it's not technically in the most proper form. So like we talked about over the last couple days when we were filling out those charts and when we were doing our special right triangle calculations, we would want to rationalize the denominator by choosing to multiply by rad 3. And this will give us a -rad 3 over 3. So the tangent at 330 degrees is -rad 3 over 3. Is everybody okay with this idea of sine, cosine, and tangent with these values? Okay, so these were the nicest values that you'll get because they're in degrees. You guys are more familiar with degrees than radians. And they're literally written on the circle, right? Because we've labeled everything from 0 to 360. The next ones aren't quite as nice because if we say like sine of 450, do you see 450 on your circle? No. Okay. So these will take a little more work. So let's say we want to calculate the sine of 450 degrees. Okay. What does it mean to be 450 degrees? When somebody does like a 720 on their snowboard or whatever, what does that mean? Yeah, they did 360 twice. They're indicating how many turns they went, right? So a circle is like infinite, but we're not going to keep labeling the numbers. We would just sit here the rest of our life, keep counting new values that it could be. So 450 means you went the whole 360 and you went some more, so to speak, okay? So the question then for us becomes how much more? So once around the circle is 360. How much more do I have to go to be equal to 450? So if you're not sure, you're literally going to take 450 and subtract 360 from it. And you get 90, okay? So 450 is an entire lap around the circle plus 90 extra degrees. That means 450 and 90 are the same, but not the same, right? If I did, which would be a feat for me because I can't even ride a snowboard, a 90-degree turn on my snowboard, it means all I did was turn from this to this, right? If I did a 450-degree turn, it means I went all the way around and back, but we both landed at the same spot, right? Okay, so 450 is around the circle and then at 90. So I'm at the same position as 90. It just took longer to get there, so to speak. And then remember, sine should be associated with what? The y coordinate. So the sine of 450 degrees would be 1. Do you guys understand that? Because it's the same location as 90, kind of, not really, but kind of, right? And then the y coordinate there is 1. So then what about the cosine of 675 degrees. So again, 675 is more than 360, but it's not more than 720. So it's like one time around the circle, not a whole nother time. So I got to figure how much extra. Again, if I don't know, I'm literally going to take 675 and subtract 360, and that gives me 315. So 675 is an entire lap around the circle and then another 315 degrees. So it lands me at the same spot that looks like 315 degrees. I just went further to get there, okay? You can see the x and y coordinates for 315. And then remember here, you're focusing on calculating cosine. Cosine works with the x coordinate. So the x coordinate at that position is rad 2 over 2. Okay? So the cosine of 675 degrees is rad 2 over 2. And then the tangent of 540 degrees, again, 540 is more than 360, and if you don't know how much, you can figure it out. You can do 540 minus 360, and you can get 180. So 540 is 360 degrees, and then another 180. So you land at what looks like the same position as 180. And you're trying to calculate tangent. So you're doing the y divided by the x. So at that 180 degree or that 540 degree location, the y is 0 and the x is -1. 0 divided by -1 is 0. Now, what if I had landed at a slightly different position? Like, what if I landed down here at 270? What's the tangent at 270? When you go to calculate the tangent at 270, you would be doing -1 divided by 0. How does that work out? It doesn't work out, right? When the 0 is trying to do the dividing, it doesn't work out. So what would you guys write in that case? Undefined, okay? Anything trying to be divided by 0 is undefined. So I'm just pointing that out so if it comes up, you're not concerned that you did something totally wrong. That could come up. All right, I'm going to erase these top ones, and we're going to go back and try 3 more, this time with negative angles. Okay. So you can see on the 3 on the board that we're going to do. We're going to calculate the sine of -45 degrees, the cosine of -150 degrees, and the tangent of -495 degrees. So for sine of a negative angle, what do you think they're trying to indicate when they're making the angle negative? Yeah, you're right, Valerie. Okay, that's right. So instead of going the normal direction that we're going, we normally start here and travel this way. They're trying to tell us you start at the same point. However, we want you to go the other direction. So here's the thing. You don't have any of those labeled. You'd have to label infinitely many things on here if you wanted every possibility labeled. So there's a couple of ways that you can figure out where -45 is. One is to compare it to +45. So when you see -45, think about it as a positive just for a second and try to understand how far around the circle that means you go. +45 would mean I would go halfway through that first quadrant. So -45 means I want to do the same thing in the other direction. So I want to go halfway through one quadrant, but the other direction, which means -45 would land in the same position that 315 is in. Is that okay with everybody for one way of looking at it? Okay. I understand how much +45 degrees is, so I'm understanding how much of the circle I'm using, but I'm using it the other direction. Okay. So sine is the y coordinate at this position. The y coordinate is -rad 2 over 2. So the sine of -45 degrees is -rad 2 over 2. Does everybody understand that the negative in my answer right here that I just put has nothing to do with the fact that the angle was negative? Okay? The negative is in my answer because the place I landed at had a negative y coordinate, not because the angle was negative. Okay? All right, so cosine of -150. So one way to do this is what we just did. First, understand how much +150 is. So +150 is almost to 180, 30 degrees away from being 180, which is halfway around the circle. So I could do that same thing the other way, which would put me at the same position as 210. So -150 lands in the same spot as 210. If you don't like that, because it does get more confusing after the first quadrant, you could count, okay? And what I mean by you could count is you either count in 30s or you count in 45s. Kind of like when we were measuring for our golf course and we counted the measurements on the ruler in like 16ths. We can count around the circle however we want. If it ends in a 5, I'd probably count by 45s. If it ends in a 0, I'd count by 30s, okay? So given that right now I'm trying to work on negative 150, it ends in a 0. If I felt really at a loss for how to get there, I could count around the circle in the opposite direction because it's negative by 30s. I just have to make sure I don't count the 45s, right? I don't want to count the blue ones. They're not part of the 30. So if I started at 0, this would be 30. 30 more would be 60. 30 more would be 90. 30 more would be 120, and 30 more would be 150. That's negative 150. Okay, the only thing that could mess me up if I counted that way is if I counted some of the lines that are for the 45s and not for the 30s. Okay, so no matter which way you get there, whether you look at the positive and then understand that as a negative or you count, negative 150 is the same position as 210, and we're calculating the cosine, which is the x-coordinate, and at that spot the x-coordinate is negative rad 3 over 2. All right, so then we have the tangent of negative 495. So this has like both things. It's negative, so it's going the other direction, and it's 495, which means it's more than 360. Okay, so we have a couple ways we can figure it out. How much more than 360 is 495? So it's 135 degrees extra after a lap. So negative 495 is like starting here and going this way, going a whole 360 degrees, and then going an extra 135 degrees. Now here's where it gets tricky. I have to figure out where 135 is, and I'm going the wrong direction from my labeling. So again, we've taught you two ways to do that. Way number one, think about what positive 135 is. So it's one quadrant and half of the next one, and do that in the negative direction. One quadrant and half of the next one. So I would land here. Other option, count by 45s because it ends in a 5, but make sure you're not using the 30 marks when you count that, okay? So if I count backwards by 45s and I want to go 135 because that's how much I have extra, 45 plus 45 is 90, 90 plus 45 is 135, okay? So negative 495 lands at the same spot as 225, and I'm calculating the tangent there, and so the tangent would be the y-coordinate divided by the x-coordinate. I'm going to go through the calculation, but then you guys will hopefully, to save yourself sometimes, and if not, it's okay, recognize a pattern here. So the rad 2's cancel and the 2's cancel. What am I left with here? 1, okay? And a positive 1 because it was a negative with a negative, so it ends up being a positive. So the tangent at 495 is 1. Actually, at all of your 45-degree angles, it will work out to be 1 because even though they have these crazy fractions as their coordinates, the rad 2 over 2's, they have it for x and they have it for y. So when you're taking something and dividing it by itself, no matter how crazy it is, a number divided by itself ends up being 1. So at the 45s, you don't really have to go through this work that we just did. At the 30s and the 60s, it was a little more complicated because we had the rad 3's and we're getting some different things. So those ones you have to write out the work. Okay. All right, so what you really need to like memorize or know well is that sine is associated with the y-coordinate, cosine with the x, and tangent is like y divided by x. Okay, that's kind of like, they're not formulas, but they are formulas, whatever you want to say. That's what you should know. But you also have to know how to navigate around the circle. So hopefully we gave you guys a couple of ways to do that, and hopefully you're comfortable doing it when they don't just give you the angle, but even if the number's bigger than 360 or negative. Okay. Any questions? Sorry, tired, want to yawn. No? All right, so we're going to have you guys work on